In this video, I want to cover making queries with KDB.AI. We're going to not only go over making simple queries, but also learn how to take advantage of KDB.AI's advanced filtering features. The first thing we're going to do is install Fast Embed in KDB.AI client. Fast Embed is the library we're going to use to generate our embeddings. And then import some packages. The important ones here are KDB.AI client and Fast Embed. And then we're going to set our environmental variables. Now, if you don't know how to do this, please refer to the previous video. I already have my environmental variable set, so I'm just going to connect to my session once again. Next, let's drop our table data if it exists. It doesn't exist in my case, so this ran pretty quickly. Now, let's instantiate our schema. Our schema is going to have an ID, it's going to have a name, it's going to have an integer age, and it's going to have a city. Finally, for our schema, it's going to have a description, which we're going to embed, and we're going to place the embeddings in our embeddings column. Our embeddings column is going to be a vector index of type HNSW with 384 dimensions. The vectors we're going to be inputting into this embeddings column are going to have 384 dimensions, so it needs to match. The reason I'm using the HNSW vector index for this case is that for this example, it doesn't really make sense. But if we scale this example to 10 million vectors, HNSW would be a very good choice. So we're imagining we're a data scientist and we're working with a really large data set. So next, let's create our table and call it data with our schema. And here I have some descriptions just of people and their work history. And now I'm going to instantiate the embedding model with Fast Embed. And I'm going to actually create a list of embeddings. And once that completes, the next step is actually going to create a data frame with all of our data that we could insert into our table. So we have our embeddings, and now let's create a data frame with some more data. And this is going to make a little bit more sense once we actually look at the data that we're inserting. So let's insert this data into our table and actually look at this data. So here's what our data looks like. We have these columns that we defined in our schema, and what we basically have is a bunch of people that have certain ages, names, live in cities, have descriptions of what they do for work, and who they are as an employee. And we have some embeddings generated based on the description. Now, the embeddings are generated with a BGE model, which is the default for Fast Embed, and it has 384 dimensions. So whenever we're going to make a query, we're going to want to use the same embedding model. KDB.AI has really advanced filtering capabilities. And these filtering capabilities are almost reminiscent of SQL. So if you're familiar with SQL, KDB.AI is going to be very simple to understand. Now, the first thing we're going to do here is we're going to find people who are 30 years old or older, and who live in Rome or Paris. So here is our query, and we have this filter where we have tuples signifying our specific filters that we want. So we want greater or equal to age 30 and in Rome or Paris. And what we get is two people. We get Monica and Ivy, who actually pass these filters. And we get this data on them. We could also do aggregations. For example, we don't always want to return all the data. Sometimes we only care about certain columns. Here, we only care about name and city. So let's search our entire database, but only return name and city. We could also do some more complex aggregations. Let's do an aggregated query for the maximum age group by city. So here we have an aggregation of max age, we're grouping by city, and then we're sorting by maximum age. And let's see what that gives us. what we find is that New York and Zurich have a much older maximum age than Seoul, for example. You could also return aggregated results, group by a categorical variable, and then sort by a column name. So here we have an aggregation where we have a tuple signifying that we want the average age, and we will also want a count city, which is the number of people with distinct IDs in each city, and we're grouping by city. And then finally we could sort by column, so let's sort by average age. And what I should get as a result is the number of distinct people in each city and the average age in every city sorted by average age. So let's see what we get. And that's what we get. We find that New York has 5 people and Zurich has the highest average age, which is 59. Now we could also filter string data to make sure it matches a particular pattern. Here we're filtering by age being less than 30 and the name starting with H. So we're matching patterns that are like H star. And what we should get is people whose names start with an H. And Hannah matches both of these filters. We could also do a filter where we check that someone is in multiple cities. So here we're checking if they are in this city list. And we get these 4 people that are in Rome or New York and are older than 30. It gets really interesting once we could combine searching with vectors and similarity search with these specific filters. So let's define a person query, which is the kind of person that we want to look for. In this case, is a software engineer with lots of experience. And let's create an embedding vector based on this. Now, with fast embed, you create a generator, so you need to turn that into a list first. And let's make sure that our embedding vector is the right size, and it is. Now we can actually search our table for the 3 closest people to this person embedding. And what we get are Alice, Mia, and Tina. And 2 of them are software engineers, and 1 is a UX designer, so that's pretty close. And we could use n distance to figure out how far they are. So, for example, in an application, we could only show people that match a certain distance criteria. We could also use multiple query vectors. Here, I have a couple queries. I have one which is the exact same, a software engineer with lots of experience, and a second query, which is a data scientist with experience in machine learning and a keen interest in AI research. So let's see if we can actually find someone who matches that vector. So what we do is we turn that into a list of embeddings, and then we search every single one of those embeddings and get 3 results for each. And we get 2 results at the same time. And the first result is the same as the previous one. But the second gives us a data scientist in Tokyo, a business analyst, and a research scientist. So it's a much harder query for our particular data. And what's useful here is that you could get faster results if you batch your queries. So let's say you're doing 10 queries at a time. It's much faster to do them in batches than to do them one at a time. We can also add filters on top of these search vectors. So let's search for the same person embedding from earlier, but now we only care about the name, city, and description columns. So we're going to add them as aggregations. And here we get the name, city, and description columns based on the search embedding. We could also create more advanced filters. Here, let's filter people younger than age 30 with the same aggregations and the same person embedding. And we are able to filter by age being younger than 30. So this becomes really useful, especially for time-based filters. For example, with KDB.AI, you could filter to nanosecond precision. So for a lot of time series data, this becomes extremely useful. And in my experience, these kinds of filters are very necessary for data science because often you want to be searching your unstructured data in many different ways. You want to search it in unstructured ways, like with similarity search. You could search it with structured filters, but it's very powerful when you're able to combine the two in robust ways without needing multiple databases and having to create all this complex infrastructure. With KDB.AI, it's very easy to get started in extracting insights from your data. Finally, let's drop our table to conserve resources. So that's the last thing we're going to do. And we're finished. Thanks so much for watching, and I'll see you in the next one.